Messages, Instances and Initialization. Introduction. In this following chapter, we will explore the mechanics of message passing. We will investigate on creation and initialization. Creation, allocation of memory space for a new object and the binding of that space to a name. Initialization, not only the setting of initial values in the data area for the object similar to the initialization of fields in a record, but also the more general process of establishing the initial conditions necessary for the manipulation of an object. The degree to which the later task can be hidden from clients who use an object in most object-oriented languages is an important aspect of encapsulation and one of the principal advantages of object-oriented techniques over other programming styles. Messages, Instances and Initialization. Message passing syntax. Message passing, that is sometimes also called as method lookup, the dynamic process of asking an object to perform a specific action. A message is always given to some object called the receiver. The action performed in response is determined by the receiver. Different receivers can do different actions in response to the same message. Although the syntax may differ in different languages, all messages have three identifiable parts: message receiver, message selector, and an optional list of arguments. The below given example shows the message passing syntax in various languages. Statically typed and dynamically typed languages. Languages can be divided into two groups depending upon whether they are statically or dynamically typed. In a statically typed language, a variable is associated with a type which is known at compile time, and that type remains unchanged throughout the execution of a program. Equivalently, the variable can only be assigned a value which is an instance of the known or specified type. In a dynamically typed language, a variable has no type and its value during execution can be anything of any shape and form. The below given example shows the variable number is a statically typed variable and the value 5 is assigned to them. When the number variable is declared as dynamically typed variable, since its value is changed due to the arithmetic calculations performed. Example, integer number equal to 5, that is a statically typed variable. Number equal to 5, number equal to number plus 15 divided by 2. This one is a dynamically typed variable. In Objective-C, a variable can be declared with a fixed type, and if so, the variable is statically typed. On the other hand, a variable can also be declared using the object type ID. A variable declared in this fashion can hold any object value and hence it is dynamically typed. Accessing the receiver from within a method. Inside a method, the receiver can be accessed by means of a pseudo variable. This is used in Java, C++ and C#. Self is used in Smalltalk, Objective-C and Object Pascal. Current is used in Eiffel. Class student open bracket integer id string name student of integer id comma string name open bracket this dot id equal to id this dot name equal to name bracket closed void show method open bracket system dot out dot println id plus name bracket closed public static void main string arguments of open bracket student sname1 equal to new student of 111 comma Rahul student sname2 equal to new student of 112 comma Anita sname1.show, sname2.show, bracket closed. The above given program simply display the ID and name of the student. The student constructor is declared to assign the value of ID and student to the current object, and show method is used to display the ID and name of the student. Two objects have been declared, and whenever the object is created and parameters are passed automatically to the constructor once it is invoked. Implicit use of this. If this keyword is not defined in accessing the variable, then it is implicitly assumed to refer as this. Class student open bracket student of integer id comma string name open bracket id equal to id name equal to name bracket closed. It is assumed to be equivalent to the following given example. Class student open bracket student of integer id comma string name open bracket this dot id equal to id and this dot name equal to name bracket closed. The above example shows the difference between the use of this operator. Two constructor declarations are same. Object creation. In most programming languages, objects are created dynamically using the new operator. Java, C++, and C#. The declaration simply names a variable. The new operator is needed to create the new object value. In C++, student star s name equal to new student of 111, Harry. Java, C#, student s name equal to new student of 111, Rahul. Python, s name equal to new student of 111, 4. Ruby, s name equal to student.new. The above figure shows the syntax used in object creation for various different languages. Python does not use the new operator explicitly. Instead, creation occurs when a class name is used in the fashion of a function in Python. Pointers and memory allocation. Pointers are used in all object-oriented languages in their underlying representation. Since all object references are in fact pointers in the internal representation, Java has no pointers that the programmer can see. Memory recovery. Memory created using the new operator is known as heap-based memory or just heap memory. Objects are dynamically allocated in most languages, so they must be recovered at runtime. There are two broad approaches to this. Force a programmer to explicitly use delete operator when a value is no longer being used. Delete sname. It is used in C++. In Java, the destruction of object from memory is done automatically by the JVM is called garbage collection. Memory errors. A runtime overhead is imposed by the garbage collection systems but prevent a number of potential memory errors as running out of memory because the programmer forgot to free values, using a memory value after it has been recovered. The below example shows the value is assigned to the pointer for the student class and delete operator is used to delete the pointer object. Delete is used to free the memory allocation. Student star s name equal to new student of 111, Rahul. Delete s name. Free the same value twice. Student pointer s name equal to new student of 111, Rahul. Delete s name. Delete s name. Delete already deleted value. Constructors. Constructor in Java. It is a special type of method that is used to initialize the object. Java constructor is invoked at the time of object creation. It constructs the values, that is, provides data for the object. That is why it is known as constructor. In C++, Java, and C#, a constructor is a function with the same name as the class. In Python, constructors are all named _init_. In Delphi, Objective-C, constructors have special syntax but can be named anything. Naming your constructors create is a common convention. Class student open bracket integer id string name student of integer id comma string name, that is Java constructor open bracket this dot id equal to id this dot name equal to name bracket closed. The above given example shows the constructor student. This keyword is used to assign the value of the variable for the current object. Overloaded constructors. Constructors are often overloaded, which means that they perform number of functions with the same name. They are distinguished by the type signature and the arguments used in the function call or declaration. The below given example shows the overloaded constructor. There are two constructors, one which accepts two arguments and another one which accepts one argument. In both constructors, this keyword is used to refer the current class instance variable. Class student open bracket integer id string name student of integer id comma string name, that is overloaded constructor open bracket this dot id equal to id and this dot name equal to name bracket closed. Student of string name, it is also overloaded constructor open bracket this dot name equal to name bracket closed. Constant values. In Java, an immutable data field is simply declared as final and can be initialized directly. In the below given example, integer speed limit is declared as final, so the value cannot be changed. Whenever we attempt to run the program, it will show us an error. Class bike open bracket final integer speed limit equal to 90, that is final variable. Void run method open bracket speed limit equal to 400 bracket closed. Public static void main string arguments of open bracket bike obj equal to new bike of object dot run bracket closed. Alternatively, a final value can be assigned in the constructor. Immutable values in C++ are designated using the keyword const. Differences between constant and final. The const modifier in C++ says that the associated value is truly constant and its value cannot be changed. The final modifier in Java only says that the associated variable will not be assigned a new value. Destructors and finalizers. A destructor function allows the programmer to perform certain actions at the other end of a value's lifetime when the variable is about to die and have its memory recovered. Whenever memory space for an object is released, it is invoked automatically. It does not take any arguments and is never directly invoked by the user. Class student open bracket student of integer id comma string name open bracket this dot id equal to id and this dot name equal to name student of open bracket cout less than destroying object bracket closed. The above given program shows that there is a class student declare the student constructor and destructor is used to delete the object. The destructor function name is same as the class name and same syntax which is used in the constructor declaration. A method named finalize in Java will be used which is executed before deleting any object in Java. This can occur at any time or may never occur. Summary. In this chapter, we have examined the following topics. Message passing syntax, statically and dynamically typed languages, accessing the receiver from within a method, object creation, pointers and memory allocation, constructors, constant values, and destructors and finalizer.